Hey guys, so I just want to go over some common mistakes I was seeing on yesterday's assignment. Um, Hopefully clarify some points of confusion that you guys had. And I'm just going to use this function as an example to start. So when we're looking at whether a function represents growth or decay, this is what we want to look at, okay? The growth factor, basically whatever is being raised to an exponent. So if this is greater than 1, we are looking at growth, and if it's less than 1, we are looking at decay. So in this case, we are looking at a number that is greater than 1, so this is going to be growth. All right, so that's step 1. And then when we ask the rate of growth, okay, we know that for exponential growth and decay, for this one, we're talking about growth, what's normally in those parentheses is 1 plus r. So what we're trying to find is that r value. That would be the rate of growth. So 1 plus something gives us 1.3. So we're basically looking for the difference from 1. Well, we know 1 plus 0.3 will give us 1.3. So this is our rate of growth, 0.3. What some of us were getting confused on is the growth factor would be 1.3. That would be what's in the parentheses. That includes the 1 that we're adding to the rate. So this would be the rate of growth, and this would be the growth factor. Now if we look at this example, where what's in the parentheses is less than 1, we know we are looking at decay. All right, and then if we're asking for the rate of decay, well, the decay model has 1 minus r in those parentheses. So basically 1 minus some value has to give us 0.86. So to find the difference, you could do 1 minus 0.86, and that would give you what you're looking for. So it looks like our rate of decay is going to be 0.14. So that is the rate of decay. And then like we mentioned before, if we want to know what the growth factor is, well, that's already there. That's 0.86. Last one I want to clarify is the Michael Scott example from yesterday's assignment. It says Michael Scott owns an antique car. He bought the car for $2,000 on his 18th birthday in 1980, and the value has increased by 2% each year since. Find the value of the car today in 2020. All right, so he bought the car for $2,000. Value has increased. So if we want to know, is it growth or decay? Increase tells us we are growing. So we're looking at growth, okay? Then the next question asked, what is the rate of growth? Well, we talked about that before. So our rate right now is in a percentage. So we have 2%. To put that into decimal form, right now the decimal is here. We got to move it over twice to put it in decimal form. So this would be 1, 2, now the decimal's here. So we have 0.02 is our rate of growth. All right, then if we want to know what the function looks like, well, we already have the rate. And then if we look back to our original problem, he bought the car for $2,000. So that's going to be our A. So that's our initial amount. Since we're talking about growth, we're going to have 1 plus because we are growing. So we need that growth factor to be greater than 1. We already found the rate of growth. We've got 0.02. And then since this is a function of time, we're going to raise it to the t power. So that's what our function would look like. You could also condense what's in those parentheses to be 1.02. So that's our function. Now to find what the value of the car today is, the only thing we have to plug in is time. All right, and then we can find out the time from up here. So he bought the car in 1980, and we want to know the value of the car today. So how many years have passed from 1980 to 2020? Well, the difference would be 40 years. So wherever we see t, we are going to plug in 40. And then that function you can just plug into your calculator. So we put in 40 for t, and we get a value of $4,416.08. I also accepted 7 cents. It doesn't matter if you round up or down, but if you rounded past 2 decimal places, that is incorrect, because when we're talking about money, you can only round to 2 decimal places. So that's something you also want to think about in your answers for exponential growth and decay.